Hello, I'm Yunso from Dongguk University DTM Lab. Today I'll be presenting a paper review on the topic Technological Trend Mining, Identifying New Technology Opportunities Using Patent Semantic Analysis. First, here is the bibliographic information of the paper. This study was published in 2022 in the Journal Information Processing and Management. The following are the keywords and highlights in this study. Presentation follows the same structure as the paper. Technological advancement is creating new opportunities, and firms need to identify technological opportunities to stay competitive in the market. Because of this, many studies have used patent data. This study aims to identify technological growth patterns and find new technology opportunities based on those patterns. Trees is known as the role of technological system evolution. It can be used to generate new technology ideas. However, trees has a limitation in that it is difficult for non-experts to use. The study aims to propose a framework that identifies the technological evolution patterns from the perspective of purpose and effect and suggests future technology directions. To systematically extract purpose and effect information from patent data, the SAOX structure is applied. 3G is used to define the action and object. The research questions of this study are as follows. Technology opportunities can be classified at the firm, industry, and national levels. They can also be classified as technology-based, market-based, or capability-based opportunities, depending on the perspective of the analysis data. This study focuses on technology-based opportunities at the industry level and aims to explore technology opportunities by identifying technological evolution patterns within the industry. This is an approach used to identify technology opportunities through technology trend analysis. Although technological evolution patterns can be studied from various perspectives such as purpose and effect, existing research has made limited attempts in this area. This study analyzed the purpose and effect of technologies in patent documents to show technological evolution patterns. By using SAOX, the study proposed an approach that addressed the limitations of previous research. The research process consists of 4 stages as shown in Figure 1. After collecting patents in the target domain and performing pre-processing, SAOX is applied to the patent abstract. Through this list describing the technological purpose and effects is constructed. Then criteria are applied to select AO structures related to technological purpose and effect, and meaningful SAOs are selected. The criteria for selecting valid AOs are shown in Table 1. The subject should be a term referred to the invention, and the object should correspond to a tree's engineering parameter. The remaining AOs represent P, C, which indicate technological purpose and effect. Buffering is applied to the selected AOs. At this point, similar AOs are defined as technological purpose and effect class. The final dictionary consists of the list of AO clusters and the corresponding AO list. To identify patterns of technological purpose and effect, sequential pattern mining is performed at the level of purpose effect classes. When exploring macro trends, the analysis is done at the class level, and when a more detailed view is needed, the internal AOs are examined. For sequential pattern mining, the data are transformed into the format shown in Figure 3. Among the derived metrics, candidate patterns that meet the criteria are extracted, and core evolution patterns are selected based on risk. Sequential pattern mining is a method used to identify frequently observed event patterns. In this process, the support confidence and risk metrics are used. The detailed explanation of these metrics is shown in the material. The technological patterns of the reference domain are used to predict the technological purpose and effects of the target domain. First, the reference domain can be selected based on user interest or industry factors. High growth domains or domains similar to the target domain can be selected as priorities. Once the reference domain is determined, the same analysis used for the target domain is applied. One, technology opportunities are derived by linking the target domain with the reference domain. When the two purpose effect classes share common keywords, they are connected and the technology opportunities are analyzed at both the macro and micro levels. Through Figure 5, technological evolution patterns can be identified at the macro level. They are classified into end opportunities and analogical opportunities. Through Figure 6, technological evolution patterns can be identified at the micro level. They are classified into diversification opportunities, converging opportunities, and analogical opportunities. The target domain of this study is the biohealthcare industry, and the reference domain is the telehealth industry. In this step, USPTO patents from 2000 to 2020 are collected. The data collection query and results are shown in Table 3 and Figure 7. COX analysis is applied to the patent abstract to extract the technological purpose and effect. Then clustering is performed and 12 AO groups are identified. Evolution patterns are explored for the technological purpose effect classes. The repeat value is used to select the key patterns. The nodes represent technological purpose and effect, and the rings show the degree of association. Based on the table and figure below, the evolution patterns can be interpreted. COX is applied to the telehealth patent abstract to extract AOs, and they are clustered into technological purpose effect classes. Symmetric is set, and key patterns are identified based on the rift value. Technological purpose effect classes of the reference domain and the target domain are linked. Through this, the foundation for exploring technology opportunities is established. The evolution patterns of the telehealth domain are shown in Table 7. In Figure 10, the end opportunity and analogical opportunity patterns can be identified. The results of identified technology opportunities at the purpose effect AO level are shown in Figure 11. From the figure, it can be seen that in biohealthcare, a diversification opportunity is identified, moving from providing diversity to automation. From the figure, it can be seen that in biohealthcare, an analogical opportunity is identified, moving from product uses support to automation. Research in the biohealthcare field positively evaluated the applicability. Also, when patent-based trend analysis was conducted, as shown in figure 12, the results were found to be similar to those of this study. The study aimed to identify technological evolution patterns from the perspective of technological purpose and effects, and to predict future evolution directions. In addition, this study will contribute to idea generation, technology convergence, and the application of trend mining research. The study has three main limitations. First, the industry application scope is limited, so there are constraints in generalization. Second, there is a need to apply analysis techniques beyond SAOX. Finally, there is a lack of empirical validation based on industry practice. Future research needs to address these issues. Thank you for listening.